think so.
Hello again. We are going to listen now Kathy Giori. She will be talking about embedded systems, and let's hear her. Kathy, please start your presentation and have a good time.
Hello, everyone.
Hello, welcome. Enable your camera if you can, please.
Okay. All right, here I am. Can you see me? Looks like it.
Almost, yes. You're live. Please do.
Okay, hello, everyone from probably the other side of the world for most of you. I'm in California, and I come to you giving you a short presentation of some great open source projects, including web things, where I'm going to give you a tour of my home, how I can maintain a smart home that's all private to me, or as much as possible private to me. So let's see, how do I advance my slides? Sorry, didn't do the presentation. Oh, there we go, right there, the right arrow. Okay, so just a little bit about me. So I've been in the technology industry for a really long time. I came out here to go to grad school, and ended up, my first job was like Fortran data analysis of electric field mills, doing all sorts of cool stuff. I've just been involved in doing things with, you know, Linux and tools and open source for a very long time. And more recently, I'm trying to spend a lot of my volunteer time applying open source technology into the education space. So I'm going to be showing you a little bit about a great project we call Microblocks, which was developed by the founder of one of the founders of Scratch. And it's how you can do physical computing with a blocks-based language. And it actually applies really well to the Internet of Things, because anything with connectivity can be turned into what we call a web thing. Now, then I'm going to skip the boring introduction about myself because the first thing I want to do is take you through some of the parameters of why privacy and security are important. I'm sure you all understand that, but basically I wrote down on this slide the concerns I have for my own home, which is, you know, security. I don't want hackers being able to attack me like they did the Colonial Pipeline recently. You know, you don't want cyber attacks. Privacy, that's like super important to me, not as important to everyone, but for me, just when a door opens and closes, when there's motion in the home, when there's network presence of the devices in the home, when lights are switched on and off, all of that type of information is really a blueprint for when people are home, when a home is occupied or not. And if that information were stored in the cloud and somehow hacked, and millions of homes, you know, tens of millions of homes had occupancy data, that would be a great, you know, dark web data set for someone to know, you know, what if you come and go for work and when to break into your home or not. I mean, that to me, that's just the tip of the iceberg. There's all sorts of privacy concerns I have, but, you know, mainly it's just like, you don't want to live in a glass house, right? And by exposing all your data, that's what you're doing. The other third main problem of smart home is interoperability. Like, you can buy into one system and use that system for everything you do, but you're kind of stuck on what that vendor offers you. And it's really hard to do your own thing or mix and match or grow it over time. So what I'm going to be demonstrating today really is a growth of something over time. I didn't like put it all together in one fell swoop. And lastly, at least for me, if I hadn't worked at Mozilla on the Web Things project and gotten my hands on a lot of different smart home devices and really got intimate about how they worked and which ones, you know, connect over a radio that's non-IP protocol like Zigbee or Z-Wave, connect only to my device. If I wasn't like doing that full time as a job, when would I ever have had the time to research all the different devices out there, all the different systems and tools? So in addition to having some, you know, interoperability and ease of use, I think the overall value is to consumers to help them understand what devices are easy to use and why, what ones protect your privacy or not. You know, those kinds of things is something we need to wrap into the whole system. So what I'm showing you today is definitely a, you know, a developer-centric view, I think, but it has commercial implications. One of the main differences in the approach we took with the Web Things project at Mozilla, which is right now, by the way, a community project. So if you want to get ahead of myself, webthings.io in one of the tabs, and you can look up the project. Basically, my home runs on a Raspberry Pi. And so in this case, the data center is the Raspberry Pi in my house. And so your home is your data center. And you only use the cloud, for example, to access from your smart home, you know, the web interface, so that when you're away from home, you can still monitor, and that tunnels through the internet over HTTPS. So it's HTTPS access only. Instead, a typical vendor, and this is just a web page, a progressive web app that I have, you know, as an icon on my desktop. So I just click the icon and I'm right in the app. Otherwise, I have loads of apps that I've had to download just for the initial installation of, for example, Wi-Fi devices. And if you have this system of all these different vendors, you end up with hundreds of like different apps, and interoperability between them becomes very cumbersome. All right. So those are some of the problems. Looking at interoperability itself, what the Web of Things does is there's a standards body group called in the W3C called the Web of Things, which this project is based on. And it just says all we're going to do is we're going to tie all these different protocols, all these different messaging methods. We're going to put them all together at the web layer so that web services, JSON definitions essentially, describe these different things, and they have actions, events, and properties. Properties being the main thing. And so new technology coming along, the one that was called Connected Home over IP is now renamed to Matter. And I think Zigbee was renamed to something else recently, but it doesn't really matter. You can bring them all together. And so your own private home consists of sort of this Web Things gateway, things that you buy. You can also build things, and then you just manage it all under one roof, essentially. And I wrote a tutorial that really needs to be updated because it's still got Mozilla branding all over it, but there is information on the wiki, the Web Things framework. There's all sorts of libraries that take, that give you in different languages ways to create web things out of data, you know, everything from Arduino and Microblocks to, you know, Python and JavaScript and Rust even. And then Microblocks, like I said, is what I use to program microcontrollers typically. And I can turn these things into web things with just the addition of a library and a few additional blocks that say, you know, I have a temperature property, and it shows me the degrees Celsius or Fahrenheit or whatever I want. Microblocks.fun is another tab to open up on your browser. And just to show you a little bit behind the scenes, when I open the Microblocks IDE, I get a library list and I have the capabilities, the properties, actions, and events. Actually, it only does properties and events in this library. And then I can create smart lights, smart motion sensors, door sensors, temperature sensors, and all I have to do is pull the blocks together. And behind those blocks, so all I have to do is, behind the blocks is the actual on. And so I can turn one of these microbit boards really easily into a smart light, into, you know, it has an onboard motion sensor, could be a smart motion sensor. And these extra blocks in red are the Web Things blocks. And all it's doing in this case is I could use a button to toggle the light on and off with the actual device, or with my web browser, I just toggle the icon on and off. And I didn't have to build a web page because the Raspberry Pi does that. And the blocks on Web Things do the rest. So IoT for education becomes really easy. Now, extending an alternative to the Web Things gateway would be to use something like Snap, where you can just build your user interface. And Snap is another blocks-based language that runs on your laptop through browser, and it's just awesome and amazing. snap.berkeley.edu. And just a little hint about how Microblocks actually works is these blocks are actually the programs that are running. Behind them, there's these opcodes that turn into machine code that actually runs on the bare metal of the microcontroller. So there's actually a virtual machine that is running the blocks. And then when you disconnect the microcontroller from your laptop, the blocks are still running in the microcontroller. So it does run in fully autonomously in an untethered situation. So it really is a fantastic language compared to something like Arduino, which I've worked for and used in the past. This is so much better. And there's a virtual machine to build for all these different microcontrollers. We use Platform.io as the tool for that because it's just phenomenal for any text-based framework that you want to build for microcontrollers. So if you clone the Git repository, you can build Microblocks for whatever boards are supported, which is in the Platform.io ini file. Just this picture, you'll see I have some online demos on my YouTube account, something about IoT and privacy. There's a Raspberry Pi and a speaker and speaker microphone. I'm going to demonstrate that live, so I'm not going to show this video. That's sitting over in the other room. And then the Web Things links, just going to show you a few links here. Webthings.io is sort of the starting point for that. I have some YouTube playlists for both Microblocks and IoT, and I can share this entire presentation. There's, if you subscribe to Make Magazine, or you can just go to the online version of Make Magazine and get it for free. Issues 72 and 74, if I remember correctly. One has the Web Things article I wrote, and one has the Microblocks article and all the different microcontrollers you can use. And if you want to get involved, this just has a bunch of information about how to contact me, and my Twitter and LinkedIn handles. And then just to note that the other thing I love about open source and community-driven projects is that early on I pushed hard to get Web Things translation into the project. The same tools, Pontoon and Fluent for translating Firefox are the same tools used to translate web things. So you can convert web things from just picking your language, and the translators wanted for all these different languages. For Microblocks, the translation is a little different. There's just that's sort of the one language, like English, translate to another language, and then once that's available, you can also change the IDE to many different languages. So this was a summary of like Microblocks, Web Things, Platform.io, Snap, 4 great, awesome open source projects with really excellent educational potential, I feel. And there's one more that I wanted to introduce for 2 reasons. One is that I started working for a commercial company that takes advantage of this Linux Foundation open source project. And the second thing, like there's a big example of it lately, the Colonial Pipeline in the east coast of the United States. They're having all sorts of gas shortage issues with people hoarding gas because there was a cyber attack on this Colonial Pipeline. And so the next project, what it aims to do is to take embedded Linux products that are deployed at the edge and make a secure conduit to the cloud for them. And rather than sort of, you know, worrying about lots of different Linux distros and lots of different applications running at the edge, there's a Linux Foundation project called Ide for sort of for a virtualization or containerized approach to the edge, where you have the thinnest shim of a Linux kernel running on hardware, and it basically does all the virtualization. It utilizes Alpines, which is really supposed to be a thin shim, and then you deploy applications through the secure conduit, and only the controller conduit can run them. So I really do have, you know, pretty good faith that we'll be able to stop some of these cyber attacks that are occurring because of all of these exposed edge IoT devices. And this project you can find on Linux Foundation and then on GitHub. And there's an open source implementation where Eve has an OS version that runs on the edge, and then you can use a command line controller, or there's a commercial instance at the company I'm currently contracted for called Zidata. And so you find that as a Linux Foundation. So that's another great project for sort of the security and privacy around IoT. Now on the demo side, I'm going to focus on 2 things. First, that smart controller I keep promising. And secondly, I'm going to spend a little time on the Microblocks side, so you can see how cool it is to be able to program, you know, microcontrollers and turn them into physical computing devices, and if they have connectivity, IoT devices. So without further ado, I'm going to share my screen. And I don't know if I don't know if it's going to be possible to minimize the slides then. So I want to close this. There we go. Look at that. Now you're seeing my web browser. Okay, so the first thing I want to do here is I need to open this window so I can actually see it. Okay, so this is what I'm sharing. What I want to show you is this is just an interface of either virtual objects or real objects. In the case of an IP camera, I have one that points outside the front door of my home, and it looks, you know, out at the front sidewalk. You can see cars in the driveway or on the street. Helps you see that. And that's just, again, snapshotted through the browser. These are sensors that are air quality sensors that come through an add-on. So the whole framework of this Web of Things is that there's a core, you know, JavaScript object notation for defining all these things in a standard way. But then once they are represented, then any object, you can open up its splat icon and see the details, and you can see various information about it. And so this air quality sensor is actually within a kilometer of my house, but it's not my air quality sensor. It's something I've pulled in the data from the internet, and so I can use it to determine when to close my windows and doors in the summer when there's wildfires in the area, which has been a problem lately. And this exact add-on, the air quality purpleair.com add-on, was a request by me, and a developer in Germany actually put it together in a day to help me know when to close my windows and doors. And so I have a rule of an upstairs screen door that if it's open in the middle of the night and the air quality, like the wind shifts directions, the air quality goes into the bad, unhealthy range, then I have the little speaker alert me and wake me up in the middle of the night, even 3 a.m., and I close the door, and all I have to do is close the door and the rule will change to stop saying that. So if I actually go into the rules here, the beauty of it, again, of being all in one place, is that then I have rules to tell me, okay, so bad air if door open. So if I look at that rule, what I was just describing, and the air quality goes above a certain amount, and the upper deck door is open, and it's an even minute, it's going to alert me with bad air until I reset, until the air quality goes lower, or I close. Basically, all I have to do is close the door. So that's really cool. And then what I said, about the beauty of the add-ons, before I take you around on tour, I just wanted to show you how that works. So there's rules for all of this, tying things together. There's logging. So I just want to quickly show you what that means. So, when the entry door was, open and closed, some motion in the TV area, which is near the kitchen area, when the front door was open, things like that. So there's all sorts of temperatures and earthquakes and motions and tides and air quality. And so all of this stuff is logged for 7 days over a period of time. And then I also have it laid out over a floor plan if I want to do floor plan view, but I have so many things now that I tend to use the other view. And then just so you know, this is a Raspberry Pi connected on the Wi-Fi network. You could also plug it in over Ethernet. The domain is something you set on your own, so you have your own private domain. I'm actually connected locally, not through the internet right now. So the whole system actually works without internet access. It all runs locally. If my internet broadband is down, my local network will still continue to function. My users is as many as I want for logging in. The localization, as I mentioned before, is just going to be for date, time, rules, and parameters, and then the languages. Pick your language there, and then also pick your units of whether you want imperial or Celsius units. I always use metric. So going back, experiments, there's developer things like you can go into the detailed logs, create authorizations, and whether you want to enable SSH into your Pi. And then the updates, at least for the Raspberry Pi version, are automatic, so it keeps me up to date. And then I'll go into add-ons is really the name of the game. And if you want to see add-ons even without having this installed while I go along, you can do web things, api.webthings.io, port 8443/add-on/info, and it shows you all of these add-ons. And what these add-ons do is it takes commercial data or internet services data, takes data from anywhere on the internet or any device and converts it into this standardized W3C Web of Things thing descriptions. And then interoperability of rules and so forth is based on having all the data sets in this common framework. So those are our add-ons. So if I go and look at the add-ons I have installed, you can see how I configure them. So the date and time depends on my latitude and longitude, and I can offset some sunrise. So I have actually outdoor LED lighting in my front porch that depends on rules of when is sunset. So rather than keep changing the time for the time, as the years change and it gets darker or lighter, I just have the lights go on at sunset and go off at 10 p.m. I never have to change the rule. And then I monitor earthquakes from the USGS online data set, and I can say how far away I want them to look from my house and the magnitude, And so we might get some browser alerts that tell, you know, when there's a earthquake. There was one right before I started this talk, but even 1.0 earthquakes occur like all day long, so we tend to get some. And then the Google Homes, I have a couple of them in my house. They're set on mute, so I don't actually use them for smart assistants at all, or rarely. I might unmute them to do something, but I use them to talk to me. You know, that I find that they're just excellent text-to-speech things. So I have all these preset canned things that I have assigned to rules. So if there's an earthquake over 5.0, I want to see where it was and how big it was, and maybe go into the USGS data site. When we're out of the home, I set a rule that there's an intruder alert, and any door that gets opened, you know, the multiple door sensors will present this, you know, loud announcement. You can also set the volume on these announcements of unauthorized persons, you know, must, you know, authority being contacted, which is authority being me, because I get Slack messages through a notification add-on. And then I have a water sensor under my sink, so if there's a leak under there, it will notify me. Porch motion, I usually use that rule off, but sometimes if I'm expecting a package delivery or something, I'll turn that notification on, and then if I'm somewhere, I'm notified that someone came onto the porch. The bad air quality, you know, that's another, you know, wildfire problem we have in California. I have my rules set up for 2022, Happy New Year, but you can have happy birthday, you know, when somebody walks in the door and the door opens, it could wish them a happy birthday. I've done that before for my husband. It's kind of fun. And then I have a couple things of just be aware, like the leak detection of the garage door left open. I have a little timer set for 5 minutes, and if the garage isn't closed after 5 minutes, then it, you know, just says check the garage door. You know, might have left it open accidentally. The pulse adapter is really cool. You can just create toggles and buttons and things and timeout things for whatever you want. I have this everything pulse, which is always on, and when I turn it off, it turns off all my powered devices like lights in the home. Very convenient. Here's that purple air adapter. Again, it's just saying how many sensors within a kilometer of my home do I want to monitor, and then I can add them to my gateway. Scene control is like red alert lighting. Again, when the intrusion detection triggers, it turns all of my lights on that are smart lights, and it turns all the colored lights into red. So the whole house lights up, and everything that can be red is red. So that's kind of a fun scene control thing. Scheduler I used a lot for the holidays. You know, I have my Christmas lights and stuff downstairs turn on even before I got out of bed and came downstairs, and you have the whole house is dark and you have the shimmering little lights, and it was really pretty. And I could set the schedule for different days of the week when I get up at different times to make sure they always came on. Slack is just a notification, again, for getting messages directly to my phone. Sonos is a way I play internet streamed music. And the Tide in Redwood City, where I go rowing. They're all, you know, like I say, most of these things are either a station where you're fetching this data or some sort of means for getting these internet services data. It's really cool to bring all of this data into you. And then another one of my favorite adapters, Voco, uses the now acquired by Sonos Snips libraries, but they were open source libraries, and one of the Mozilla developers initially did a demonstration of it, and another guy in the Netherlands picked it up and made it even a lot better. And you basically have a speaker microphone, and you speak to it locally, and it implements these you know, commands, the same commands as I can do through my web interface, I can now do through my voice. And it has some extra things like setting timers and setting something on or off for a certain amount of time. So it's that is just like one of my favorite add-ons. There's another one called Voice Control, but it uses the Mozilla Deep Speech Library. It doesn't actually work as well, so I recommend Voco. And then the weather, again, is just latitude and longitude of where I am. And the web thing is actually the sort of the standard. And so when I build things with Microblocks, I use the Wi-Fi things show up as just standard web things. And then I have a couple other devices, and I use a lot of the battery operated things I use. Almost all of the, probably all of the battery operated things I use are Zigbee because it's a very good low power, protocol. In fact, I have, right here is a backroom motion sensor. And so that's works really well on battery. So I just mentioned the voice. So before we do anything, I just want to say that I can test, like if you're worried about your voice commands, is it detecting your voice commands correctly, or is it just that the system isn't set up to understand what you're trying to say? So you do need to know the name of the things. And if you know the name of the things, and you can say, so like turn on TV bulb for 1 minute. And I can send that, and that turns into a timed event. And so it says, and she's gonna, little speaker will announce when it goes off. So now we can go over to that area, and at some point this TV bulb is gonna go off. So let's go over here and see, this is the TV bulb that went on. I could, use maybe we'll go over there and we'll change the color of the bulb as the first thing we'll do, using my voice. So now, let me just check. Can y'all see? Okay, so you see the screen, and then you'll be able to, I'm gonna show you sensors like right up there. So hopefully I'll do my best. There's an actual door sensor up there for backside door, but now I'm gonna walk you over to the main hub of things, which is the Raspberry Pi. Oh. So she just announced that she was setting the timer back to off. So now we would have to actually go in there. I'm just going to turn it back on again. And then I can say, hey, Snips, turn the TV bulb to orange. Setting bulb to orange. Okay, so now the TV bulb is orange. You can see that this is the TV area motion sensor. So the motion sensor is triggered. And then this is the Google Home that we can pretend that something has happened, like if the garage door was left open.
Check the garage door since it seems to have been left open.
And so that's the type of alert I would get when something like that happens. I could also, if the bad air quality happens.
Check air quality. It's moving from moderate to unhealthy.
And so it just alerts me in significant earthquakes and things like that. And so now we have this TV bulb on. I also have a Sonos connected, and I can say, hey, Snips, turn on the Sonos. Setting flame of Sonos to high. Okay, and so what happens is now this is turned on, and if I walk over here, it's finishing up a commercial, and then you can see, hopefully, the orange of the light, and I also have a physical button. This is an IKEA Zigbee button, so I can turn things on and off, the music on and off with this. I could turn it on and off with the playing button, and right now it's basically just playing Radio Swiss Jazz, and so I can just also turn it on and off just like that. Okay, so that's pretty cool. This, the color of this can be all sorts of different colors. So if I turn it to, let's say, magenta, then you should see it change right there. And then I just want to show you, it's all the simple things that are actually really useful. Like the entry door to the house is through this garage door, and it's right here, a Samsung SmartThings sensor. That should be this door right here. And so when I open the door, you see that it shows that it's open and closed. And I can trigger various things based on those actions. And Then over here, I have some outdoor, I don't know if you can see, but outdoor cafe lighting out there. And I have this button I could use to turn it on. I don't know if you can see those lights turn on out there. But I can also use my voice even from across the room. I can say, hey, Snips, turn off the string. And she says, setting power string to off, and it turns off. And then I have this virtual button that's everything that just says turn everything off. I click it and all of my lights would go off. So again, there's just going to take you on a quick another little tour of different devices. Near my, this is my front door. So if this is open, and I open the front door, you'll see front door active. And then out in the front, actually, this is like the picture of stuff, the picture from the other thing that you saw, and I have strip lighting right down here. These are the LEDs right down in the rocks. And the cool thing about those LEDs is because they're colored, I don't even have to set up lights for different seasons. And Christmas time, I have 2 strips. One is red, one is green, and Halloween they're orange, and Valentine's Day they're pink, and 4th of July they're red and blue. And so that's the garden lighting, which is somewhere here, down in here. And then here's all my air quality sensors. I have a whole bunch of them. I have my Slack alerts. I have the Tide in Redwood City. I have the earthquakes, which right now there's nothing active within 500 kilometers. Let's see. I have like front hall motion sensors. This is a little IKEA one that's firing right now from that. I have a desk lamp that goes on automatically at sunset. I have, buttons scattered throughout the house just for turning things on and off. And I just want to show you a little IP camera. Now the IP camera, I still don't point inside my house because it's Wi-Fi and it's connected to the internet as well. It sits right here. I don't know if you can see that, but it sits in this front laundry room. So, and there's also a tiny little, whoops, I just dropped it. Sorry. Tiny little Zigbee. This is a Xiaomi device that does temperature and humidity. So if the humidity was too much, that might be a problem. So, and then upstairs there's door sensors. There's, if I show you, there's a garage door sensor. Again, I just use a normal door sensor for wanting the garages on and off. This is the outdoor LEDs in the garden. And various powered things. The lamp has a timeout. Other doors. And that's, there's the themes or the scenes that I can set to different things. And again, the logging of all the data is really, really useful. So I'm going to wrap up with that home tour and make sure I leave some time for questions on that later. But now I'm going to stop sharing that one, and I'm going to instead, and if there are some questions you can ask me interactively, you're welcome to. Otherwise, I'm going to show you how you can easily make your own smart home devices. Hope that was somewhat fun. You can see I've built this home, over a period of time. It's not like I did it all at once. Okay, so now I'm going to share another application, and this is the Microblocks Ide. And so what's going to happen is I have this little device I was playing with like more than a week ago. It's a little servo that I can control the motion of, and it's a little grove sensor. And I don't remember what application I had on here. I was like, what did I have? And so Microblocks has this awesome feature of the blocks I remember are on the microcontroller, and I want to just open from board. Oops, wait. Before I do this, I need to share. Never mind. Okay, share your screen. And let's see. Select window. Microblocks and allow. Okay, now I'm sharing Microblocks. Okay, so this IDE again has many languages. You have to get the firmware on a microcontroller once in order to do it. But right now, what I want to do is I want to open from board. And it says to plug in the board. So I'm going to plug in this board right here into one of my USB ports. And it has a little Grove sensor servo. And I plug in the board. Oh, sorry. I plugged in the board from the wrong place. I need to plug it into the microcontroller, not the extra power sensor. Okay, so plug in the board. Whoops, there we go. Now it's reading the project from the board, and it's taking the blocks on the board and basically decompiling them, and should show me the blocks on my screen when it's ready. So how convenient is that? And so now I can look at my code and say, okay, when I press button A, I'm going to move this servo. Well, first of all, down when started, it has a set pin 2 to, or set the servo pin 12 to a certain amount. So if I push the A button, oh wait, hold on. Push A and then push B, it would move. However, the servo takes a lot of power, and it can't drive it off the 3 volts. So let me just move this back. Now I know what code is written on here. Let me just do a quick experiment here. Now I unplug the device, and it complains. And I have to apply the power to the board that has the servo. Now I know what the code looks like, and I say, okay, press button A, what's going to happen? It spins around. B, it spins one way, and A, it spins another way. And so now I know what this does. And I just want to show you the really cool part about Microblocks is, unlike make code or some of these other things, I can do stuff in real time. It's live. And so I'm going to plug in an LED strip here onto another pin. And this time again, I need to plug into the board. And then I say, rather than this servo thing, I'm just going to say new. Get rid of that project. And I'm going to load the NeoPixel library. Again, there's a whole bunch of different libraries for different devices and things. And then I'm plugging it into, I believe there should be 30 LEDs on here attached to pin 2. And let's start that. When started, let's define that. So if that works, then we ought to be able to just say, set all NeoPixels to green, and lo and behold, they all turned green. And so now you can do all sorts of fun things with them. You can do loops. You can, like do from one to another. I could change the color right here to make them all pink, and just click the block, and it's live. It just does it. And then this actual board has built-in basic sensors, like tilt sensors and the acceleration and so forth. So if I accelerate it more, you'll see those differences. And it has this cool block of graphing or say that you can use. And so you can take these sensors like the light level, and I say, like forever, maybe with a little bit of a wait, 50 milliseconds. Put that inside the block with the say block. So I have the light level here, and now if I cover it, it goes lower and like higher. But in addition to say, I can graph it. So let's duplicate this block and graph it. And then I can have the light level here. I'm going to put 0 at the bottom. And let's see if we can play that. And now, if I cover it, you see that go down, you see it go up. And so now I can look at the light level. And I could do other things, like instead of the light level, I can do the tilt sensors. So let's do X. And then also Y, whoops. I also want to do Y. And let's just clear this. And then I want it back at 0 in the middle. And then I want to forever show X and Y. And now you can tell if I tilt it one way, which sensor, and then if I go this direction, I believe it's the Y parameter. That's the green one. And then this one is X. And then Z is flipping all the way around. So they're actually a 3-axis motion sensor. And then if I shake it, you'll see the. So there's libraries like for step counts, step counting, and all sorts of cool things. And so this is a really fun, absolutely like coolest thing in the world because it's so live. Like the first thing you do in Arduino is you blink an LED. So this has a little LED light that you can turn on and off, and I can just do that. And if I could just pull these blocks out, and forever I can turn the LED on, maybe wait 200 milliseconds, duplicate these 2 blocks to turn it off, and then, when started. And this is essentially Arduino Blink. But of course, if I wanted to make it more fun, I do the LED display instead of just one LED. I pull this part out, and now I should be doing a happy face blink. Oops, wait. Instead of, so I can just change it in real time. When I realize I make a mistake, clear display instead, we'll pull that out. So now it's doing the happy face blink. And so you can realize how easy it is to do these things. And then the libraries for web things, going back to IoT, is under network. There's this web things library, and I click that, and I open it. And it has a library of things that basically do all of that JSON description behind the scenes for you. And so now I have, I set a thing name, I set a capability like a light. So let's call this a Microblocks thing and a light, and I can just give it a Boolean property. Like I have to define at least one variable. So I add a variable called on, and then I set on to, true or false for starters, something like this. And I could even do the LED strip, for example, to be on or off. And then I give this title on, and then I start the web thing server. And then all I would have to do is like wherever this becomes a if. So this becomes if on. I grab the on variable. If on, I'm going to set all of the pixels to pink. Else, I'm going to clear the neopixels. So we need an else here. Else if clear neopixels. And then I get rid of all this other stuff. And so now, and just to be able to test it, let's do a little control. So when when button A is pressed, let's toggle on to the opposite of itself. So let's toggle on, oops, to not on. Not variables. Sorry, it's hard to do all this one-handed while I'm holding this. But now, basically, if I start this program, it creates a web thing, and I toggle the button, and it goes from on, which it started, to not on. And so now there's my toggle, my button. And then at the same time, if I were just to look at the web thing JSON, let's see, there's a thing description here. If I look at that, this is what the description in JavaScript is, and I can connect this to the Raspberry Pi and run the Microblocks add-on. This doesn't have Wi-Fi, but I could do a radio remote control to one of them connected to the Pi and then the other one remote, and I have lots of these things. And I could do servo motions to open or close something. I could do lights. I can do motion detection. I could connect one to a door. And so you can use these microcontrollers to basically create all of the different web things that I showed you from my commercial devices. And so I just wanted to show you a few of these other devices that I've built as web things. This is a web thing IR controller, and it's a little this is the M5 stick C, and so it has a little user interface display, and then I can use a remote control to toggle it. This is, I have a couple more microbits that I just turn. One I use for temperature and light, and one I use for the lighting going on and off, just as a button press. This is another bright LED that I use for things. I have my own indoor air quality sensor that I have hooked up to a Wi-Fi device. So this is also programmed using Microblocks as a native device. This I have set up, this is called an M5 stack, and it has a motion sensor, PIR sensor connected to it. So I put this somewhere, and this is a battery, built-in battery, so it can run for a little while, not forever. I usually leave it hooked up to a battery brick. And so all this fun stuff basically becomes build your own IoT devices. And then I also have, I'm sorry I don't have it set up, but I had all those devices hooked up to this Raspberry Pi, which also has a Pimoroni blinked Pi hat on it, so I can do individual colored lights on the Raspberry Pi that's running the Web Things gateway directly. And the way you set these things up is just a micro SD card. You flash it with an image, you plug it in, you boot it on your network, you connect it to your local Wi-Fi, you give it a domain name so that you can access it remotely, and then boom, you're ready to go. So the last thing I'll mention here of the Microblocks is there's all sorts of cool, fun games and libraries. If you look, under the microbit and the Calliope boards, you find tons of fun games you can play with it, as well as music and all sorts of things. So I have tons of different examples. There's also, just so you know, Web of Things has its own examples of how you can set this thing up as a heart rate monitor, temperature and light, push button, hello, LED, ambulance, lots of different things. So in fact, if we do the ambulance thing, I'll just show you really quick before I stop sharing this. This has the ambulance basically uses the, let's say that we do the 30 LEDs on pin 2, and then attach the buzzer, I think is on pin 0. And let's see if we can play that. So the red blocks are basically setting it up as a web thing, and then I have button A to toggle it on and off. So this is my little ambulance. And then toggle that. And so this actually works as a web thing. And I will stop sharing that.
Okay, Kathy.
Yeah.
You have a few questions. If you can reply to them in the sharing notes on the left side of the screen.
Okay. Let me see.
The remaining few minutes, if you can.
All right. So in the remaining minutes, let me go over to the chat window. Is that where I'm supposed to be?
Yes. Shared notes.
No, public chat or just shared notes? Shared notes?
Yes.
Okay. I'm going to the shared notes right now. Questions for me. Okay. Tour of that is, have you written documentations or reviews of these different systems? Not really. Documentation, there is the wiki or Web Things project will take you to the wiki, and there's some documentation about devices we know to work. And my base recommendation is look up some of the information. If it's a Wi-Fi device, you have to be very careful about whether or not it's getting out to the internet or not, and block it. But Zigbee or Z-Wave devices or anything that's non-IP is going to be good. And then look at the add-ons, because they will tell you a lot of information about the different devices. Is there any major implication when IPv6 becomes a standard in terms of security embedded systems? Again, IPv6, you're going to have to treat it just like Wi-Fi or anything that has an internet accessible protocol. Then you have to know that you're blocking that device from the internet or not. And I think in future versions of the Web Things, there's one guy that set up the Raspberry Pi gateway as the access point, so all the Wi-Fi devices connect to it. And then he has an add-on that basically blocks them unless he wants them to talk to the internet. There are future applications where you have an appliance and something breaks. You want the appliance manufacturer to be able to remotely check the information, but it's something you just want to turn on for the time of that, remote service call, not always monitoring what you're washing in your washing machine, right? And so it really depends on the protocols to investigate that. What's your opinion for, is Tor hidden service the perfect tool for exposing IoT home server behind? So the current encrypted channel that I'm using it's PageKite. And so it is tunneled just to me, HTTPS only for my username. So I'm fairly confident with that. But it does have a cost, and right now that cost is being bared by volunteers, and we're trying to turn it into a nonprofit that can cover those costs. There's another tunneling service called NKN, which is a blockchain distributed service, and that does work also, but it's a little cumbersome to set up. So I'm hoping we can add an add-on that you could use the NKN tunneling, or you can just, you can open a port through your own broadband service provider. You just have to be very careful who has access to get into that port. Let's see. Besides encrypted channel, only the service. Automatically hacking attacks simply don't know where is your exposed server. No one should know you have a smart home, right? Yeah, I totally agree. The smart home privacy to me is very important. And what worries me most about these centralized service providers having access to all our smart home data is like one hack exposes millions of homes. At least in the case of decentralization, where each of our homes is a data center, they have to hack into one home at a time, just like physically they'd have to hack into one home at a time. And if you're in Russia, physically accessing my home is pretty hard, and but remote access is easier. So I just have to maintain that security of HTTPS from the outside as the only way to get in. Are there IoT devices talking in a proprietary protocol? Well, yeah. So how does Web Things deal with it? Any wireless protocol or messaging protocol that's proprietary is fine, as long as at some point there's an API that's exposed or can be, reverse engineered into getting those data. Now, there are some that are like Nest, which is like a secure pipe from the device to the internet, the Nest internet and back. You can't tap into it. There's no Nest add-on because Nest does not expose any information locally. And it's a real pain to get it from the cloud. What are your opinions of the Home Assistant project? So I've built one. It wasn't hard to spin up, but I found that I didn't spend a lot of time on it because it requires all these like TOML configuration files, and I really felt like the web things is something I could set up in my mom's home and my cousins and my friends and family, and it really doesn't require any configuration files that are difficult. Like they can then learn just the add-on config file is just a web page, and they don't have to learn special things. So for Home Assistant, it's great for, there's a lot of flexibility for developers, but not a lot of flexibility for non-tech people, is my sense. Maybe it's improved since I last tried. And then data explosion. Do you think that, quote, data explosion happens when we save this data, typically in a cloud? Should our devices be more forgetful? Yes, absolutely.
I would like to add something to this question. I
Okay.
saw a little bit earlier the detail of the data logs in one of your slides,
Yeah.
and in the perspective of a non-technical user, that is a huge amount of data that is being saved. I'm not sure if in a cloud or in our laptops or something like that. What will be your opinion about all these concerns about privacy and data leakage and
Right, right.
all
For
the
myself,
private information being sold in black
yeah,
markets?
I don't want my data saved over time. I have a 7-day rolling window where the data just purges and rolls off. There is like an InfluxDB add-on. So if you're an industrial setting or a commercial setting, you might want to store data, but you might want to do it as a what are those RDB, the sort of where it crunches the data the older it gets, might be a way to log it. I personally, for smart home use, I think you should throw it away unless there's some real good reason to keep track of it. And someone else wrote an add-on, Timon in the Netherlands, where you can actually set up periods of time where it's not logging data from a privacy standpoint. Like when my housekeeping service is home, I don't want to keep track of everything while they're in here. And so I just have it not logging during those times. And so I think we really need to enable consumers to keep very careful track of what is being logged and the privacy implications. There's a lot of things to be done.
Absolutely. Thank you.
And then what other cloud services can we use other than Google Cloud to potentiate the features and usability? Oh, well, I don't think we need to use commercial clouds at all. In my case, I think we should all be our own clouds and run things locally. And other online services, even if you trust the vendor of it, the vendor can get hacked as well. So you have to be careful. Is there a way to set up a secondary Pi to take over in case the main one will fail? Yeah, it's as easy as just backing up this certain WebThings.io directory. I back that up periodically, and then you can just bring up a brand new Pi and just upload that directory, and your whole Pi is back to normal. So there's also satellites that someone has done for the voice control, so you can have satellite voice control in different rooms. Any hardware kit already pre-installed? Yes, OKDo actually has, OKDo.com has a WebThings Gateway Raspberry Pi 4 kit, but it's only the Raspberry Pi part. And then on top of that, I would just get a Zigbee adapter and a bunch of Zigbee devices you can buy from IKEA or anything. Can you show add-on for a cat? We use Microblocks to write it. I don't have time to show a cat, and I don't know what you wanted exactly, but Microblocks for writing your own IoT devices is really cool. It's super fun. I highly encourage people to play around with it, and there's a wiki on Microblocks that has a little information about how to set up the Raspberry Pi gateway, and then a few basic web things applications you can write with it. So sorry I blabbed too much and ran out of my time, but I hope you got some fun out of it.
Yes, absolutely. Thank you, Kathy. And we're going now for another short break.
All right. Thank you all.
Bye-bye.
Bye.
Hello. Welcome back, everyone. I really hope that you have enjoyed all the sessions and all the talks today. We are so happy to have our next presenter talking about sandboxing your data with Tracker by Carlos Garnatro. And I hope you enjoy the presentation, and good luck to you, Carlos.
Thank you, Christy. So first a small introduction. I'm Carlos Garnatro. Maybe you don't all know me. I've been a very long time contributor to GNOME, and for a less long time I've been working at Red Hat. So yeah, well, this talk is about Tracker. Tracker, maybe you've heard of it briefly, or you had some experience with it. It has a long story. Well, it was a file system and metadata indexer, which became a file system and metadata indexer trusting in a cool technology, and which became a cool technology surrounded by a file system and metadata indexer. So I'm talking about this, the core thing of Tracker, and I trust, maybe you don't know that much about it, about how it works internally. So, well, I've approached this talk so you can go from not knowing that much about Tracker to having a reasonable understanding of how it works and how it approaches storing data, and how it approaches sharing data with others, and how it can be used. So yeah, well, I have quite a lot of slides to go through, so let's pace through it. So RDF is the core storage of Tracker. It stands for Resource Description Framework, and well, it describes grabs some information. We'll get more in depth about that. And it's one important thing to note is that it's more of a concept, not a specific format. It's not XML, not Turtle, not JSON, not DE. There's infinite ways to represent RDF, and RDF is not tied to any. So it can also be stored like we do. So, and well, as I said, it describes graph information, and the basic unit of it is a triple. And what is a triple? So yeah, a triple consists of subject and predicate and object. So here we can see it at big turtle to represent it. This could be how you can see in some places how a triple is represented. It can be compact in different ways, or well, it can. But let's pick this representation. So here, these two things, they represent information themselves, and well, we can see that the subject can be an URI, but also a blank node, but let's not get into that. Well, they are simply just ways to represent anonymous data and whatnot. It's not worth to talk about them. The predicate can be an URI, and the object can be an URI or a literal value. And this is essentially how we can imagine this information. This could be two nodes tied by an edge. The predicate is a label to the edge, and the edge has an arrow. So this is why you can read somewhere that RDF is a labeled directed graph. So the important thing to note is that triples work by composition. So yeah, you here have the basic unit, so you can put them together, and for example, here we can describe here on the right hand we have the RDF describing the graph that I'm painting on the left side. So we can say that, for example, a song is a song. We give it a duration, and we give it a title. We give it an artist, and the artist can be a node on itself. So, yeah, well, too many conversion formats. I'm missing some some emojis over here. Never mind. So yeah, the artist can be a node on itself. So we can say that the artist is an artist, and we can give him a name, etc., etc. So yeah, for example, here we are relating the song to a file, to a physical file, and we, for example, are relating the file back to the song. So this is how you construct the RDF and how it becomes a graph. It doesn't matter where you start from or what order you put it, that the resulting effect is the same. You get the same graph based on the same RDF. But we are not a shapeless metadata store. We don't store arbitrary data or typos or things like that. Things need a structure. For example, here, well, let's go through that. And what do we need for that? This is what we use ontologies for. Ontology, well, is another of these buzzwords that take a bit long to describe, but let's go to the basics. And they are basically the description of the allowed data. And they allow us to define classes and properties. The classes would be, in the example before, going back, this is slower than expected. Here would be, the classes would be telling that you store songs and you store the ability to store songs. So you define a class for songs, or you give it your ontology the ability to store artists. So you define a class for artists, and the properties could be the properties that can be created on resources of these classes. Yeah, going forward again. So yeah, and for example, we have other things that we can define in the ontology, like for example, just defining classes and properties is not enough. So yeah, we can actually say the range of these properties. The range would be basically what kind of resource can this arrow point to. So we can define, for example, that duration in this example here can be an integer. But so this could be, there's also a missing check mark over here. This could be a valid node that would be allowed into the database, because the ontology defines that duration is an integer. But for example, if we insert some string, it could be something disallowed. So we keep consistency that way. And there's also, we can also define the cardinality of these properties. For example, I don't know, getting back to the topic of songs, one album can have many songs, but each song can only have one duration. So this could be allowed, but trying to insert multiple nodes with different data, that could be incoherent. So that would be disallowed. That would be, there's also a forbidden mark over here missing. Yeah, it ate all my emojis. So yeah, and in the ontologies you can also set up the indexes and other miscellaneous data, like the documentation of the ontology itself, and other things like defining full text search properties, so you can quickly search through text on specific properties or other characteristics of the database. And one important thing to note is that ontologies are also defined on top of RDF, and this is an RDF store, so we are actually, the ontology is actually introspectable. So, well, I'm not going back that many slides, but as I pointed out before, that the property can be an URI, so the property can also be a node with other properties and definition and whatnot, and you can, the language allows to query all of this neatly. Yeah, and back to the talking about the language. So Sparkle is actually the core technology of Tracker, and it's a query language for RDF graphs. It is well, Sparkle 1.1 is a W3C recommendation from 2013. And it hasn't been seen that many updates since. So it's pretty stable, and well, it has some dark corners, but what doesn't? So yeah, it's overall a pretty solid base for Tracker. And how does a query language that is based on graphs work? It does work by specifying graph patterns. So what you do actually in Sparkle would be, here's for example an example query. I'm not going to get that much into the language itself. I didn't to get too technical here. But here's, for example, an example query that's that is basically defining a triple with a placeholder, which is $u, which is a variable, which we are retrieving here. So we are actually saying that the predicate must be X title and the object must be Y. So the only way to satisfy this, it would be, in this case of this graph, it would be song1. So, but the important thing of these graph patterns is that they would match anything that goes with that graph pattern in your graph. So any song which would have that title would be returned by this query. And there's many other ways to retrieve data and to query around and whatnot. For example, this other query is also a graph pattern that matches this orange marked triple, but we are retrieving the predicate here. So yeah, well, we are basically asking the title of the song, song1. And so on, so forth. Here we are asking the title for any song that has a title and would match song1 here, but it will also match any song and will give you the titles and songs. And as I said, this is introspectable, so we can ask for the properties and this anything and what property has the object Y. So we can, in this case, it would tell us that song1 has a title that is Y. So yeah, there's many ways to. This is a very complete language. Here's, for example, trying to match, matching more complex graph nodes, like saying, yeah, this artist must be A. A here is used as a placeholder, which would match this, and we say that the name must be Joe. So it sets the connection between the nodes, and we get you, which could be someone. So yeah, and there's actually many ways to do this. Really, Sparkle is a very complete language done for this task. So yeah, well, also talking about Sparkle, yeah, in this time frame, it would be crazy. It's a complex language, but the basics are basic, but yeah, it's a deep language. That would be the best word. So yeah. And yeah, well, the Sparkle language can also work on multiple graphs. It doesn't. I've been talking about graph in singular or graphs in indeterminate plural, but it can actually work on multiple graphs. It by default has an anonymous graph, which has no name, and it has other named graphs that it also has a graph keyword in the query language and different ways to put graphs, so you can do unions on them and whatnot. And how this works really is, you have also by composition. It works by composition. You layer your graphs, and they can talk about the same things, or they can talk about different isolated things, or really the data. Different triples can be in multiple graphs at the same time. There's different ways to store the data and to use graphs and to mix them and whatnot. But it also allows federated queries and can work across remote services. And how does this work? I'm luckily it works very similarly because I'm lazy with my assets. And yeah, well, it works pretty much the same by composition. So you have local data and you have remote data, and you can query it. You can actually merge it. Everything is an URI. Every node in the graph is an URI. So you can uniquely identify things between services and match them together and retrieve data from other services that match your local data and whatnot. And one important thing to know is that Sparkle is a language made from an unreliable web, which means that the web is not static, is very far from it, and services can go offline, data can change, that is out of your control. There can be data migrations that change to different formats that you weren't observing first, and Sparkle is made to be fail-safe in these situations. You can safely fail, or what happens simply at the query level is that the graph pattern, if it doesn't match anything, it doesn't return anything. So you don't have service access failures, or you don't get library errors from from it just because data is not in the format that you expected. So it's a query language shape that is thought for variable landscapes and different data moving around and changing. So a bit more on topic. So Tracker, I've finally made it here. So Tracker is an implementation of a triple store and an RDF store with Sparkle 1.1 support. It's fairly compact, it's fairly fast, and it's quite versatile. You can create your private databases, you can create in-memory databases, you can access remote services, it's got all the Sparkle tools that could be expected from it. And it's suitable for private data. Everything I talk about talking about to other services and whatnot, it's really optional to use. We are actually based on SQLite 3. So yeah, it's made to be actually Tracker started in the mobile world. So yeah, it's made to be fast, and it's also focused on having you create your own connections right now, at least with Tracker 3. So you can create your own connections, you can define their ontology, and you have your own local data, which you don't share with anyone. So everything on top about talking to other services, everything is optional. And yeah, well, endpoints and portals, this would be about the purpose of the talk, which here and with endpoints, this, as I said, Tracker goes private by default. It creates a local, the Tracker Sparkle connection new creates a local database, which you specify which directory it is in and which ontology. So an endpoint would be something on top that actually makes that database exported outside, on the outside. So that could be the network, but here for the purpose of portals, actually the assumption, as I remember, as you may remember, sorry. As you may remember, the network, well, the Sparkle language is network oriented. So here we are assuming that it's the bus. So, and we said about earlier before about Sparkle being made for an unreliable network and unreliable conditions. So here we are changing with portals the approach for it being random to it being actually constrained and actively constrained. So what we have is a portal service that is actually a proxy between the client, the Sandbox clients, and the services, the Sparkle services. And you can actually define on the Flatpak info what data is available for the Sandbox application. You can define which DBAS service is it able to talk to, and what graphs, DBAS service, as in Sparkle endpoints and what graphs it is able to see in them. So yeah, you basically define what data is your application able to see on the outside of the Flatpak. And of course, you can use Tracker locally inside the Flatpak for your own use and everything. So what would happen here? More emojis missing. So what would happen here is that, yeah, this would be the red rectangle would be an inaccessible graph, and the green rectangle would be an accessible graph. So what would happen in essence is that every node that is in the inaccessible graphs is invisible. So you have the graphs you can access, they have their own coherent information and they don't need to rely on other graphs to do that. You can merge them and they provide more complete information and everything, but it is not necessary, and you can constrain your access to specific graphs. So here, for example, we don't want you to know information about songs, but we don't want you to know information about everything else. So it can be done. And yeah, let's try to do a demo about this. Maybe it makes things a bit clearer. Okay. So yeah, so this is working stuff. These are Flatpaks from FlatHub, I think. And I'm going to use GNOME Music and GNOME Photos as an example. So here, yeah, we can launch music. It shows music. That's great. Okay, that's good. So yeah, here I'm inside the Flatpak, and there's the Tracker 3 tool. So yeah. Here I'm trying to talk to the Tracker miner, which uses a Tracker endpoint to export its data. And one important thing to know here is, like as I pointed before, here below would be the policy for GNOME Music to access only audio files. So the thing is that, yeah, well, we specify because this is all generic. So yeah, Tracker Miners is a Tracker endpoint, but there could be also other services that use this, and the Flatpak could be accessing those session services in a sandbox manner. So yeah, here we have to specify the miner, but and we say that its audio graph is what the only thing it can access. So let's try this, and let's be bad and try to see if I can access photographs, for example. So we can say photo. Yeah, there's nothing. But however, here's some data. Let's try to confirm. Let's print the URL. Yeah, this is music. Yeah, MP3s. Perfect. So it can see music, but no photos. So let's go, for example, to photographs, to photos, the GNOME app. And here it should happen the opposite. Okay, here we get stuff for photos. They are JPGs, etc. That's cool. And let's try the same with music. So yeah, I'm unable to access music. So yeah, this is actually, I'm now outside the sandbox, and I could be able to access all of it, essentially. So here's photos, and here's the music. So yeah, this way you have well, what tracker miners does in this case is having it's pre-filling the information. It knows that we want to compartmentalize the information in different graphs. So it essentially writes on its graph, and then applications can access one or the other, but not all of them altogether. And again, all these things, they are free for use, for private use for your application, or for session services that might make use of complex stores that or that might make use of actually complex queries from the outside. And yeah, and there's more. I mean, Sparkle is also very much about being able to access the data in every combination and way. So you can, it's pretty complete to do from data dumps, serialization, conversion to other ontologies and other formats. There's quite some utilities over there that are useful, and of course that could help with importing and exporting data between applications that exchange, sharing some data or whatever. But next slide, yeah. But also it's got some network transparency, as in, yeah, you can query your own data, you can query your other services with a service keyword, and that could be used for also Tracker 3.1 earned recently an HTTP endpoint implementation. So you can actually, again, this is optional, everything's optional, but you can export your data actually on the local network or on the outside. So that actually allows for different, it opens quite some other possibilities, as in, you can migrate data between your computers without actually transferring files yourself. You can automate the synchronization. There's quite some things to explore over here. It's all of this is very, very early stages, but yeah, it's got quite some potential. And yeah, this is about it. You can find us at the Tracker IRC channel at ircgnome.org, or you can, there's a Tracker topic also at Discourse, at Gnome's Discourse. So you can feel free to join and chat and ask things. And as I said, this is something that could be nice. I mean, it scales nicely from private applications to services that need complex ways to export and exchange data. It's got quite some different levels of usefulness, so I hope you find it useful.
Thank you very much, Carlos, for your presentation. We have a few questions for you. Those are the shared notes.
Yeah, let's go through them.
The first one, why would I choose Tracker over other SparkQL implementations?
Yeah, that's, well, one would be speed. I mean, as I said, we are implemented on top of SQLite, and we've been traditionally very focused on speed and being lean and whatnot. So yeah, I'd say that actually the most similar implementation that would be around, it would be RDF Libre, because that's a library, so applications can use SparkQL and queries in a similar way. But yeah, I wouldn't say that there's that many SparkQL implementations that are desktop friendly. Most of them are gigantic databases and complex engines, and they are not something that an application can pull. Yeah, the next one could be, could I develop KDE software that makes use of Tracker? There used to be a Qt wrapper for it. It was from the Nokia times. It's I don't even know where you can find it right now, but it is possible. You can. I mean, it uses glib and a main loop, but it can be reasonably hidden on top of a wrapper or something. The next question, what resources are available to learn how to make the most from Tracker and SparkQL? Yeah, that's a good question. We are, the main focus, I'd say, right now is actually trying to improve the developer experience. We have quite some documentation, but yeah, some of it is work in progress. We have a tutorial which is work in progress. That's sad, but yeah. Outside of Tracker, there's plenty of resources, but yeah, well, I wouldn't know which one to recommend specifically, because yeah, they tend to be either too technical, getting into algebra and jargon, or too basic. So so yeah, it's, but as I said, yeah, that's something that is something that would be nice to improve, and help is welcome. So if you can learn on the way and help us with that, that would be great. And next one, is there any successful stories over using such databases? While they seem very powerful, its use seems limited in the standard desktop usage. I think most of the limitations are because precisely because there hasn't been any worthwhile implementations. RDF-lib is Python only, as far as I know. So yeah, it's there hasn't been that many implementations that you can use without pulling a huge database engine, basically. So yeah, this tracker history has also come a long way. I mean, the Sparkwell 1.1 support is new in Tracker 3.0, which is 1 year and a half ago or something like that. So it's not like it's been developing to what it is right now. And I think that's it. Well, if we have 5 minutes left, I think. So
Yes.
if there's any more questions. Oh, and I actually didn't answer about the successful stories. I mean, there's quite some stuff in GNOME that you can look at. As in, it's been ported already, everything to Tracker 3, and it uses this approach to using Tracker. So it's everything is already there and working and works.
Okay. Thank you so much, Curtis, for your presentation. In case that you have more questions for Curtis, you can also reach him out on the IRC.
Yeah, please do. Thank you.
Thank you for joining us. We'll meet again in 4 minutes with the last presentation of the day. And don't forget that after the last presentation, we have the Kung Fu class as our social hour. Hello, welcome back everyone. Now it's the time for the last presentation of the day from Salt Hill, and we'll be talking about making dollars and cents of free software funding's future. I hope you'll enjoy the presentation. And the stage is yours, Salt.
Excellent, thank you. Can I get a confirmation that the mic's working? Okay, excellent. Great. Well, thank you very much. And boy, today has been a little rushed. I just basically had to reconfigure my audio setup, so thank you all for making it. A bit buzzy. Buzz is gone. Okay, let me know. I am working towards that. Let's see. So, yep, today's talk is making dollars and cents of free software funding's future. Do I best control this? Is slide switch? No? I'm not seeing the news. Oh, there we go. Okay, it's just taking a minute to load. All right. So, who am I? Why am I here talking to you? Well, first of all, I'm Salt, and I'm here because I believe in a big and little f free society, people, planet, future, world, culture. It's kind of one of the things that's been driving my interest for a long time. And you can find me at AltSalt pretty much everywhere, .net, in different places. I've been using Linux since 1996 and speaking and organizing groups and conferences and whatnot since about 2005. But recently, I've been spending my time kind of in a few core areas. So the first one is academia. I recently got my master's thesis submitted and defended just over a month ago, and I've been spending a lot of kind of energy and time doing that for the last 4 years. Right now I'm in a PhD program to continue with that. Thank you very much. And my focus has really been on tech policy and then peer production communities, policies, and whatnot around all of that area. So kind of our space. My second area has been events. And specifically, for the last 8 years, I've been involved with Seagull, the Seattle GNU Linux Conference. You can see a little seagull here, a little seagull there, seagull everywhere. Our ninth event is 9th year is coming up, and we have announced that we're going to be virtual. So please check us out. CFP will be out sometime next month, but that'll be November 5th and 6th. And the last one is crowd matching. So this is kind of an area I've been involved in for over 5 years now, and part of what I'm going to be discussing today. So I'm technically the community director of Snowdrift.coop, and we've been a OSI incubator project now, and we're about to graduate and move on to actually being launched and making some of this stuff a reality. That said, we're also waiting to hear back from the FSF High Priorities Project Committee. And we've applied, and we actually wrote out, I think, quite a good thing. So if you have some time to read that blog post, I'd recommend it. That's me. What are we here for? What is today? So looking at the really high level, I'm going to talk to you about a wicked problem. And the wicked problem is that everything comes down to coordination. It's kind of the defining characteristic of Homo sapiens. This ability to coordinate, to have shared systems of understanding. They enable us to have a society. They let us build these amazing things. But sometimes these things are harmful. Sometimes they're great. Currently, knowledge commons exists in this attention economy. And that introduces surveillance and advertising, which is a whole bunch of not so nice things. But what alternatives do we have? And what would a world look like if we were just free to create? Well, what we're going to be talking about here over the next 30 minutes or so, is we're going to go through the definitions so that we're kind of on the same page about things. I'm going to give you a brief history of public goods funding, talk about kind of the current state of funding, how it's, how we are funding this stuff, and then some of the solutions that are actively being worked on. So these are the, one thing is kind of our project, but there are others. And then the future as I see it, the future that kind of hoping to build with all of you. So starting with the definitions. Now, there's a lot of terms that we could go over. I'm gonna not try to belabor some of them. If you want to go deeper, I'm happy to have those conversations elsewhere. But there are a few that are kind of valuable for moving the conversation forward. So the ones that I want you to keep in mind as I go through these are the public goods, the commons, free Libre open source software, tragedy of the commons, and free writing. Make sure that I do not disturb my computer's up. Okay, so let's start with what are the public goods? What is the commons? Now, public goods as a term is a concept from economics. It was attributed to Paul Samuelson in 1954, and then expanded by Richard Musgrave and Garrett Hardin in the 60s. Its current form, as we understand it, was kind of put forth by Elinor Ostrom in 1990. Now, what you see on the screen here is the Ostrom 2x2 matrix. It's displaying 4 types of goods, and they're differentiated by these kind of 2 characteristics. So the first one is rivalry. This is whether something's usefulness is diminished through usage. And the second one is excludability. That's whether the use can be restricted. Can you exclude people from it? Now, examples of each of these 4. The one I like to say for a private good is like a piece of clothing, like a hat. If I'm wearing the hat, you can't also be wearing that same hat. A club good is, again, somewhere where you put a wall around it. So usually you might think of an amusement park, right? I mean, private club good. Then there's common pool resources. Now, common pool resources are these areas where there is rivalrousness. There's a limited amount of resources, but it's not excluded. It's not excludable. It's commonly accessible. So an idea here might be an ocean full of fish. Now, ocean full of fish, everyone has the fish, but you can imagine that there are a limited number of fish, and so it is a common pool of resources. The last one, and the one we're going to talk about a lot here, are public goods. Now, public goods can be thought of as things that everyone can share, and sharing is not diminishing it for anyone else. The one that I like to talk about, but it's only my hope that it will continue to be a public good, is clean air, right? This idea of like, I'm breathing air, you're breathing air, that's not, in a broad sense, diminishing the air quality. All right, so that framing of economic terms kind of gets us to what the public goods are. It explains a little bit about the commons. We'll come back to that shortly. The next big area, and I know this is going to be common to most of you, but is free Libre open source software. Now, in the 1980s, Richard Stallman, RMS, came up with this idea to turn copyright back on itself, and what we commonly refer to as copyleft. And the idea behind that is to really turn things that are otherwise being licensed and restricted into public goods. Now, it's been extended outside the scope of software, things like Creative Commons, and it's also been misappropriated, right? This open source washing. And despite the arguments over the years, I just go with flow, right? I'm going to go with the flow. Free, Libre, open. I actually think each one brings something different and valuable to the conversation. But just to be clear, we are talking about the free software movement, and specifically, when things are flow licensed, they become public goods. Again, not to get into the difference between the terms all that much here, but that is actually part of what my thesis is about, and breaking down this idea of permissive and protective, because the copyleft stuff keeps things public goods, whereas the permissive licenses only make the initial instance a public good. But there's two kind of related, like deeply related items when we talk about free Libre open source software, FLOSS, and I guess public goods in general, but public goods and the commons in general. So the first one's called the tragedy of the commons. And this is actually related to that older term, like I mentioned, we'd go back to it, of the commons. This talk I gave earlier this year at Libre Planet, and I was a little bit retired. I was just going through things, and someone actually pointed out that I kind of conflated the history of the commons and the public goods and all of that. So I'm trying to make that a little more clear. The history of the commons extends back to at least the 1550s in Great Britain, likely before then. But the tragedy of the commons was first written about by William Forster Lloyd in 1833 and brought into modern attention, as well as actually being named Tragedy of the Commons, by Garrett Hardin in 1968. The idea behind this is commons will collapse if they're overused, right? And not only that, that a lot of game theory basically shows it's in everyone's, maybe not best interest, but it's natural to overuse these resources. Now, Ostrom demonstrated that it's avoidable through proper governance. Actually, yeah, how quickly can I pull out the Ostrom book, Governing the Commons? So that's the tragedy of the commons, and we kind of know about it, and we'll get back to why we're defining these terms fairly shortly. The other big problem that's often discussed is the free rider problem. Now, what this is that through the widespread use of public goods, without providing support back, we get degradation. We have excess pressure on those people who do support the public goods, right? If everyone rides the bus for free, who pays for the maintenance, right? And of course, buses aren't maybe always the best, but transit as a broader system. Now, this talk is mostly going to focus on public goods and the free rider problem. And when I think of public goods, what I really think of is public information goods. That's because, as I've come up a few times here, thinking about what a public good is can be tricky when you're talking about tangible things. They often talk about national security or the radio wave spectrum. It takes a lot of work to get that abstract concept. But if you think of it as information, information can be shared without it costing barely anything. It does cost some time, some electricity. There are things like that, but the costs start going away. They become minimal. And by having the costs go away, it can be a lot easier to conceptualize these things as true public goods, as long as they're staying non-excludable. Now, what I think of when I think information goods, I think of software, as we've discussed, and I think of research. I think of journalism, and to some extent I think of art, though not all forms of art, but many. So now that we have the definitions down, I want to start talking about the history. And this is so that we can kind of discuss the context with which this conversation is taking place. And I'm going to be approaching this from discussion of journalism, funding journalism, which is going through patronage to the people, to some extent back to patronage, before we talk about that model in terms of software and a broader software ecosystem. So, journalism. Oh, sorry about that. Moving through my slides a little more quickly. Journalism was initially funded by those who could afford printing presses. Right? These things are by no means cheap. There were few of them. And if you wanted to print something, you had to go to the person with the printing press. They made those decisions. Right? Yes, there are legal frameworks that were brought up to even restrict it more. But when it came down to it, that's what happened. But as time went on, the printing presses became more affordable, became more democratized, some might say. And the funding structure behind journalism switched to really relying on classifieds and like advertisements. Rolling back a little bit, I'm talking mostly about journalism in the context of the United States, as I'll touch on momentarily. As the classified ads became free online, right, as we had Craigslist and other things, the power was really placed more and more with just the advertisers, to the point where they drive the message. This gets back to that idea of the attention economy. The idea that if you want money, if you want to pay your journalists, you have to run things that the advertisers will give you money for. So that means that you're running things that are more shocking, things that are maybe not as useful in the traditional journalistic form. Now, some countries, why I was speaking about the US here, have actually a different model. They state sponsor their journalism. They state sponsor their news. Now, one that comes to my mind often is France. And this type of sponsorship, this type of funding, has problems, right? There are things you can't say if you want to keep your funding. But it does allow the news to be more focused on the civic issues, on things of the public interest. Because the news isn't being directed. It does have corners where they don't want you to maybe look, but and not that you can't, but like if you want to keep your funding and that type of thing, but it's not being directed in that same sense. And so if we think about that model where it was like very directed and then kind of went to the people and is now moved back to being directed, versus it was very directed, and instead of moving kind of to the people, it moved to what we might think of as a larger sense of people, the government. And so it doesn't have that direction, but it also is being funded by this large entity still. So that arc, I see it in other public goods. And specifically, part of why we're here is I see it in software. Now, initially, software, before we even conceptualized it all that different as from hardware, it was funded by universities, right? The idea that graduate students were working on these things in the military-industrial complex. but then it was freed to what you might think of like the public, though of course most people didn't have access to computers or the available knowledge to interact with it. But it was freed, and these public goods were, you might say, funded through development effort, right? There's still the energy and effort going into them, but it's hobbyists were able to interact with them. Now, as an ecosystem, FLOSS communities, they have to keep the lights on, right? Have to eat, pay rent, have servers. And so the developers ended up getting hired on by companies more and more. And that means their efforts do become directed, right? They get directed away from flow projects because they have to sign CLAs, CAAs. They have to work on the majority of the time on this project versus the project they may want to work on. This kind of brings me to this term that one of my favorite old papers. It's called cooking pot markets. And it was described by, sorry if I'm butchering the name, but Rashad Ghosh in 1998. And the idea is that the cooking pot is full of public goods. And so when you add more of these goods, because they're public goods, everyone can take out without the pot diminishing. So it just grows, gets better and bigger and richer. But what's stopping FLOSS from growing? Like we have absolutely grown. We do see all of these areas where we have operating systems. We have BIOS. We have these great graphics programs, and there's some places we're absolutely doing well. But in general, right, we're not growing to this true point of being able to be competitive, at least in my opinion. Unfortunately, I want that. Now, what I think the reason is that the ecosystem of software, of free software, is actually not public goods. It's a commons. And so we need to sustain that ecosystem as we would with the commons. We need to sustain the developers, not just keep putting in public good code. If you don't sustain the developers, you see these vulnerabilities, right? You see Heartbleed, the lack of getting new developers, spending the time, spending the money, and that path towards competing, like truly being competitive with proprietary software. Just I don't think that it is going to happen unless we start worrying about this being a commons. Developers are humans, and in our current system, humans need funding. And of course, we do live in a society where there's funding. It exists. We're here, right? We're here at this amazing event. And part of that is that there are people already shoveling, in the sense that we'll get to. There are people who are already engaging, giving of themselves, right? We've gotten here. But really, the funding comes from two kind of large spaces. I should say three, but for what I would consider like good funding, we have individual funding and we have institutional funding. And then we have the thing I would like to avoid more, and we'll get to, which is manipulative funding. So, yes. All right. Questions? I don't see the shared notes because that will take me out of the presentation mode, but I will take a look at those after I'm done, or if you drop them in the chat. So let's talk about individual funding. The first one is through donations. I mean, this is the traditional funding source everyone has and thinks about, you know, can you please make a donation? But these are often one time, right? And they're boundless. There's no floor, there's no ceiling. You can give as little or as much. And that doesn't really connect with the project needs, right? If the project needs $1,000 to hire an ad agency to be able to produce something, they can't get it through like asking, this is how much we need. And there's not really this guarantee of impact. There's nothing that says that if I give my $5, that's going to sustain the project. Even if I give my $5 a month, it's not going to sustain the project necessarily, unless as we get to wealthy enough to really be getting load. Their big space in individual funding is newer, but it's become very popular, and that's crowdfunding. Now, crowdfunding is kind of in two camps. We have the all or nothing one-time crowdfund. So this is Kickstarter. These are producing something, everyone working towards a goal, getting to the goal, and making it happen. It's great. It's good. It is going well. We've seen a lot come out of this. The other camp is these ongoing pledges. But the ongoing pledges are made with a variety of levels. They're made with, I'm going to give more than you, and so I get earlier access, right? I get the little extra trinket. And so that's of course, like the Patreon model. But both of these lose their effectiveness when it comes to public goods, because you can't exclude people, right? And they're not rivalrous. Rivalrous doesn't necessarily matter as much with these, but the excludability definitely does. Because both of these, you're giving at the different levels because you're getting something more than other people. It's not based on because you have more necessarily. Now, the other two in this individual funding space have my Tux tea for my Teagle, Tux tea mug. We have pledge drives. Now, pledge drives are kind of crowdfunding, but they're older, more traditional, and they're really effective, especially because they don't have those thresholds, but they still are like kind of a time-bound thing. But they require wide-reaching communication, right? I'm sure many of you have listened to NPR, and that annual pledge drive comes around. You've been on Wikipedia and you've seen the drives. They need to hit a lot of people to raise the amounts that they're looking for. And they also are really maximized when there's this matching, this idea that someone's very wealthy and I'm going to match however many people up to this point. And so that really attracts people because they know that it's not just their money, it's their money and others. And so it grows faster, and they're willing to make those little gives because, again, with that wide communication network, they really can kind of have some assurance that they're making a difference. The last one's a little different than all of those other categories, and this is bounties and commissions. This is the idea that I'm only going to make progress if the price gets paid, right? Which restricts creativity because now I can only work on the things that are being paid for. And there's this potential for sabotage. As sad as it is, I can make things that people will want to pay for so that they will then pay the bounty, and I'll work on them. It just hasn't seen that much success in the broader sense. Now, moving to institutional funding. With institutional funding, we have three big broad spaces. We have grants, which are people and organizations that have all this money, and they are trying to support the social good and or avoid taxes. That usually comes with restrictive terms. You can only spend that money on certain things, and often it's these large funds, which a project that has been getting $5 here and there suddenly gets $10,000. What do they even do with it? What happens when that $10,000 goes away and they've hired people, right? Do they then have to work more on these grants? There's sponsorships. often with direct strings and again, limitations. Sometimes this is indirect. This is the idea that you have 20% of your time to work on something free, or that you just have a job so that you can fund your side project working on these things. And those provide these subtle influences, sometimes through advertising. The last one, the biggest one, the one that's like the greatest source of public goods funding right now is taxes. This has all of the political arguments we could make about bureaucracies, and really a lot of it comes down to poor distribution. It doesn't go to the projects that are needed, which leads to underfunding. So the last one, just touch on here, is malicious. This is what I really get to when we talk about this big divide, right? This is the idea of providing something for free of charge in exchange for making you the product, right? They do that through manipulation and surveillance. The game can have control over the consumer. So what's being worked on right now, right? Wearing the Snowdrift shirt, pointing to the Snowdrift picture, clearly involved with Snowdrift. Well, there's a number of things. First one I want to talk about is Tidelift. They're pretty cool. They're approaching this challenge of how do you give money and support and fund those libraries like SSL? How do you fund the stuff that no one sees? And they do it through basically maintaining updates and charging the big companies and projects that are using those libraries, and then passing that out and distributing it. There's GitHub sponsors. It's been discussed somewhat more, but it's great. It's great that you can get so many people, so many eyes on these projects, because GitHub is this huge software forge. But because it's such a huge software forge, well, it doesn't necessarily give money to, again, where it's needed, and maybe it disperses it too much, and it still has a lot of these problems where there's still donations, right? Still going into some of these current models. And then there's Snowdrift. And I'll talk about Snowdrift real briefly here, but then there's also tons more. We've compiled all the research, but we've done research on over 700 of these public goods funding sites, and it's on our wiki, and we've compiled hundreds of them, actually showing it because they were the more popular, more interesting ones. Now, Snowdrift.co-op, crowd matching for public goods. Snowdrift is, I've been working on this thing called crowd matching. The idea of crowd matching addresses some of these questions and points. So each month, you donate, you pledge. The amount you donate is really small, like 1/10 of a penny small. But it's that number times the number of other people who make that same pledge. And so what happens is that as more patrons join, you end up giving a little more. And not only do you give a little more, but everyone else gives a little more. Because it gets back to that idea of you're all trying to support the project. You're all there coordinating to really push something forward, to make something sustainable. And mathematically, it's interesting in that the current idea behind this has a linear growth in the amount you give, but a quadratic growth in the amount that the project receives. So we're different, as you'd expect. As part of why I'm here, part of this community, part of why I'm interested in this project. We're different because mutual assurance, that's the big thing, the coordination problem, that's what we're hitting. And it's ongoing. It is a subscription type model because it's sustainability is what we care about, right? We don't just want to launch the project, we want them to actually run. We want them to be able to hire full-time developers, full-time designers. We only work for public goods. Sure, the model could be and is, to some extent, our places are trying to work on it, but really this is for public goods. It's addressing a problem that doesn't have a good solution. And I should say, we are definitely addressing the projects that are more end user focused, projects that are things people see and touch and use, not necessarily all public goods. Right now, we've talked a lot about this being more software driven, but we definitely want to support journalism, research, art. But really, it makes sense for public goods because of all of the things we discussed about what makes public goods public goods. We don't take any fees. We are like a free Libre open source software project. We're a public good, and we expect to use our own platform to fund ourselves, which of course puts us as a nonprofit, and we have been cooperatively operated, and in the future, this is the area we work in and care about. So I'll make the call for help. We need it. We've been around for a long time, and we're still not launched. We have a ton of technical work. We have a ton of knowledge work we've done. But we don't have quite enough to get there because we're all volunteers right now, right? We haven't gone out and gotten those grants. We haven't gone into these systems of funding. So if you're a developer, or if you know developers who are interested, front-end dev, CSS, we're using Elm and Haskell, and happy to talk about that more later. And that's our back end as well. Organizational, it costs money to write terms of service. You can copy boilerplate all you want, but we actually care. We want them to be understood and reasonable for people. Could use program managers, bunch of volunteer cats. And of course, getting all of this cooperative stuff structured is always valuable. Community, I'm the community director by title, but we all wear a lot of hats right now. But it's writing, outreach, moderation of the different communication platforms and channels. And so we have a how to help page. It's a little bit crusty, but check it out. And here's some of those platforms, right? We have the forum, we have IRC and Matrix, email, Mastodon, Twitter. Probably end up in other places if we have more help. So I do appreciate anyone who can help out. I'm gonna almost end here. Basically talk about what is the future. Right? We've talked about these being wicked problems. Wicked problems mean that one approach won't suffice to fix them. It means that all of these projects need help. And there's been some policy pushes, more so in Europe, but I'm really excited about them. It's these ideas that anything that's tax funded should be flow. The public should own any public goods that were created using public funds. I mean, that just makes sense to me. Beyond platforms and projects that are trying to fund public goods and enable this funding, time is one of the most invaluable resources, right? Valuable and invaluable. People are willingly giving theirs today, right? They're shoveling that snow. And I didn't really touch on the game theory problem about our name. I'm short on time, so I won't right now. But my interest and why I've transitioned kind of from a practitioner to a researcher, it stems from this vision. This vision of what if we're, instead of talking about 8%, 10%, 12% unemployment, we were considering 60%, 70%, 80%. Now, COVID-19 pandemic, it has been a struggle. We're at this virtual conference. And of those struggles, unprecedented, as I'm sure we're all used to hearing by now, that word, levels of unemployment. And the economy has not yet totally collapsed. Hopefully won't. It's pretty interesting. I'm interested in what would it look like if we didn't force people back to work. Would they create public goods? Would they give more of that time and move us towards a big and little f free world? Could this lead to the free software movement utopia that was discussed by Stefan Martin in 20 years ago in Milestones on the Way to the GPL Society? I don't know. I don't know if the future is going to be UBI, UBS, blockchain economy. I'm not sure. But I do know that I want to believe that we'll be in a more free, Libre open space than today. And finally, just to close, Snowdrift has been active for many years. Despite not launching, we've been deeply engaged with these conversations and topics, producing hundreds of pages on our wiki and elsewhere. And recently, we've had this discussion surfacing about our own missions and goals. And no decisions have been made, but I'm pretty excited for this potential where we consider crowd batching just one of many projects and experiments that we think through, that we release in a just kind of setting, some sort of a group that's thinking deeply about the future of sustainable public goods. With that, so thank you very much for all of your time. Really appreciate it. And I do want to shout out to Slide Carnival, and one of my students introduced me to this. It's pretty neat. Everything was released CC BY, and they don't say that. They say, you know, it's free to use, public, private, commercial. I went and hunted out, it's CC BY. It's great. It's great that my students are using CC BY public flow license stuff. Again, Siegel, November 5th and 6th, virtual. And please feel free to ask about that. And yeah, I think we have maybe a few minutes for questions here. I'm at altsalt.net, Salt on a lot of IRC matrix places, and of course using CC BY SA. So with that, thank you very much. I'm going to click on the shared notes and see if it breaks everything.
Thank you very much for your presentation. We have 2 questions for you at the shared notes.
All right. So the first question here is on yesterday's talk about Cretus funding. Hala said that she's not so interested in focusing on features requested by companies because most don't support the project, whereas individual users are more likely to support. So what are some funding options where more people who are making use of the software get to support the software? And that's definitely, Snowdrift that's exactly what we're looking at. There are a lot of other ones, and if you go to our wiki and look at, I think it's called the market research section, it talks about other crowdfunding projects. And there are some that are currently active and working. I don't want to just name them because, again, we looked at like over 700. And we've explored why some are better or worse than others. The hope is that Snowdrift will be the one that I can point you to in the very near future. And the second question here is what do you think of Blender's funding model? I am not immediately aware of Blender's funding model. If someone wants to put that either in the notes or chat, because I want to research it right here. But I know that at least in part, Blender's been super, super successful in, I think they were like maybe the initial crowdfunded project, like on the internet. They've been super successful in being one of the more industry like winners. And so I assume that part of that funding comes from the education around Blender and the commercial use around Blender and things like that. And that's really great for something that's achieved that scale and that competitive position. But that's not the kind of projects as a whole. This is the chat here. Let's see. And what open prioritization? I am not sure what this one is. Let's see. If I click on this one, break everything. I always worry a little bit about it breaking everything. I hit a 404. That's because of the markdown. I have this issue with other sites. Experimenting crowdfunding to prioritize new features, implementations for browsers. So it sounds like a Bounty type of system. I'll have to look into it further. I don't think it's on our page yet, but it will be now. And again, I think with that, we're at the end of the time. So thank you so much for having me. I hope to see you in the future. And thank you very much.
Thank you very much for your presentation, and thank you all for joining us today. This was also the final presentation for the second day of the conference. We are looking so forward to have you tomorrow in the last day of the conference with some other awesome talks. And we'll see and meet each other again in around 30 minutes for our super cool social event on Kung Fu lessons. So see you in 30 minutes. Bye, and have a very nice evening or day, depending on your time zone. Thank you.